Hello everybody, welcome to NEET Physics by Arun video channel. In today's video, we are going to solve a multiple choice question in the chapter, the lesson, dual nature of radiation and matter. Dual nature of radiation and matter. This question has been asked in the NEET examination in this year, 2023. Okay, a photon and electron, mass of electron is small a, have the same energy, capital E. The ratio lambda photon divided by lambda electron. In our slide, we have put the symbol lambda p and lambda e respectively. Of their de Broglie wavelength is how much? C is the speed of light. So as usual, you are given four options: square root of e by 2m, square root of 2me, c into square root of 2m divided by e, and the fourth option is 1 by c into square root of e by 2m. These are all the four options. See, we have just seen in your previous video, in the yesterday's videos also, we have found an expression for lambda p by lambda e. The ratio we have found. So this is a similar problem, but both the questions have been asked in the NEET examinations. This question has been asked in this year NEET examination 2025, and the question we have seen yesterday has been asked in AIPMT, All India Pre-Medical Test, which are similar to NEET examination in the year 2013 it seems. Okay. So how to solve these questions? Energy of photon, capital E, is equal to h nu. According to photoelectric equation, E is equal to h nu. Plus chi E of electron, that will be a different thing. So it is equal to hc by lambda p, because nu is equal to c by lambda, that you know. To specify that it belongs to photon, you have put the symbol lambda p. So wavelength of photon is equal to lambda p. So lambda p goes to the left hand side and the E comes to the right hand side. So it is E is equal to hc, lambda p is equal to hc divided by capital E. So this is the wavelength of photon, that is equation 1. Then what about electron? We have seen that lambda E, de Broglie wavelength of electron, h is equal to h, lambda E is equal to h divided by square root of 2m into eV. M is the mass of electron and E is the charge of electron and V is the potential at which it has been cut. So this EV, the product EV, gives you the kinetic energy of electron. So the same energy, so the since EV is equal to E, that is the kinetic energy of electron. The energy EV is converted into the kinetic energy of electron. So instead of EV, we can write capital E, since EV is equal to capital E. So lambda E is equal to h divided by square root of 2me. So now we have equation 1 that represents the wavelength of photon lambda p, and the equation 2 that represents wavelength of electron lambda e. Now what is our aim? You have to find lambda p divided by lambda e. That is your answer. Okay. So dividing equation 1 by 2 will get lambda p by lambda e is equal to hc by e, the whole divided by this h by 2e. So lambda p by lambda is equal to hc by e whole divided by h divided by 2e. So instead of dividing this, you can inverse the denominator and multiply. That is a mathematical formula. So lambda p by lambda is equal to hc into square root of 2me divided by denominator h in the h, he. So you have h in the numerator, h in the denominator. That will go. That may be straight down. So c c the square root of 2m. So c into square root of 2m. So inside the square, in the numerator you have e, in the denominator without square root you have e. It means what? In the denominator you will have square root of e. So in the numerator you have c into square root of 2m. In the denominator you have square root of e. That is equal to what? C into square root of 2m divided by square root e. So the ratio lambda photon divided by lambda electron is equal to C into square root of 2m divided by E, the same energy that which is possessed by the photon as well as the electron. So option 3 is the right answer. Okay, so we will see one more question in this chapter, real nature of radiation and matter, in our next video. Till then, thank you one and all. Okay.